This is intermediate algebra assignment for April 27th. It's 11.2 through 12.5, part B, session number 1 on video. There's the assignments: 11.2, 21 through 26, 11.3, 43 and 44, 11.4, 11, 12, 15 and 16, 11.5, 15 and 16, 12.1, 15 and 16, and 12.2, 15 through 28, and 12.5, 17 through 32. On 11.2, it's all about using the quadratic formula. Before you use the quadratic formula, you've got to get rid of parentheses, such as on number 21, you would use FOIL first on the left side. But number 22, I didn't need FOIL, but I got rid of the parentheses. 7p squared minus 14p plus 2p plus 8 equals 3. Then make sure you combine like terms and set it equal to 0. So 7p squared minus 12p plus 5 equals 0. Then you put it in this formula here, the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. I went ahead and squared the b. It's always positive. In there it's 144. Then notice the work to get 1 and 5/7. You finish it. When you know the square root of your number, like we know the square root of 4, we finish it out this way. Then number 23 and 24 already equal to 0. We just put them in the quadratic formula. Again, as I've shown here, your A is 1 on 24, your B is 2, your C is 2 also. You put them in the formula as I've done there. Remember, B squared is always positive. Then we got these numbers here. This is a good example. It was negative 2 plus or minus the square root of 4 minus 8. 4 minus 8 is negative 4. Remember? So the square root of negative 4 is 2i, remember. Then cancel your 2's, all of your 2's out of every term. Negative 1 plus or minus I. Number 25 is shown there. X plus 5, x minus 1 times each other equal 2. Use FOIL first and then set equal to 0. 26. I didn't have to use FOIL, but I used a distributive property. X squared plus 2x equals 2. Then I made it equal to 0 by moving the 2 over. Put it in the quadratic formula, as I've shown here. Shown the steps here. Then I came up with negative 2 plus or minus the square root of 12. Make sure you break down that square root of 12, and that's over 2. Break down the square root of 12. It's 2 radical 3. Then you cancel a 2 out of every term. Negative 1 plus or minus square root of 3. Number lesson 11.3 is some special type of equations. They're not really quadratic equations because they're not second degree. Sometimes they are, but they're just special equations, such as 43 and 44. They're alike. 44 is y to the negative second minus 8ay to the negative first plus 7. You see it's in 3 terms. A lot of times when things are in 3 terms equal to 0, you can factor, as I've done here. Y to the negative first and y to the negative first, what starts off each parentheses. And then minus 7 and minus 1 to get the plus 7 and give us the minus 8 in the middle term when you use FOIL there. So then I set each factor equal to 0. Y to the negative first minus 7 equal to 0, so y to the negative first equals 7. Remember, y to the negative first is 1 over y. So that means I get y equals 1/7 because 1 over y equals 7, so then I've got the reciprocal. Y to the negative first minus 1 equals 0, so y to the negative first equals 1, and then the reciprocal of 1 is 1 over 1, it's still 1. Then 11.4 we have these inequalities here, 11 and 12. 12, x minus 6, x plus 2, greater than 0. If you look at that, you can see that your x would be 0 from the first x. From the second quantity, x minus 6, x would be 6. From the third one, x plus 2 equal to 0, x equals negative 2. So those three numbers divide our number line up. The smallest number is negative 2. So we go from negative infinity to negative 2 as one part on the number line. Then negative 2 to 0. Then from 0 to 6. And 6 to infinity. That's how they divide up the number line. I try to see if what parts of these, like the first part, negative infinity to negative 2. I pick any number out in that interval. Anything between negative 2 and negative infinity. I went with negative 3. I stuck it up in the original. Negative 3 here for x times negative 3 minus 6 times negative 3 plus 2. So this one was negative 3 times negative 9 times negative 1. All three of them were negative. Three things negative times each other, that's negative. Is that greater than 0? No. Then I went to the second interval. I chose a number in that interval. Negative 1 is probably the most common one you'd think of, or there's all kinds of decimals, but why work with them? Put negative 1 up here. Negative 1 times negative 1 minus 6. Remember, negative 1 minus 6 is negative 7. So negative 1 times negative 7 is 7. And negative 1 plus 2 is 1. So 7 times 1 is positive 7. So is 7 greater than 0? Yes. So this interval did work. Then I go to the third interval from 0 to 6. Pick any number out in there. I picked out 4. 4 back up here. 4. 4 minus 6 is negative 2. 4 plus 2 is 6. So I had 4 times negative 2 is negative 8. Plus times 6, is negative 48. Is that greater than 0? No. Negative 48 is not greater than 0. Then I go to the last interval, 6 to infinity. There's infinite number of numbers between 6 and infinity. I chose 7. So 7 times 1 times 9. 7 times 1 is 7, times 9 is 63. Is that greater than 0? Yes. So this interval and this interval worked. So here is my answer. From negative 2 to infinity, negative 2 to 0, with parentheses because there's no equal to, so no brackets, union with the last interval, 6 to infinity. Then, doing the same thing, even though it's fractions, x plus 7 over x minus 2 is less than 0, is number 15. Well, 16 is another fraction, x minus 5 over x minus 6. The two numbers I'm going to work with to divide up the number line are 5 and 6. So negative infinity to 5, and then 5 to 6, and then 6 to infinity divides up the number line. Did this interval work? Negative infinity to 5. I pick out any number between those two. I chose 0. I'd get 0 minus 5 over 0 minus 6. So negative 5 over negative 6. Negative over negative is positive. That's a positive number. Is that greater than 0? Yes, if it's positive, it's greater than 0. Then I go to the next interval. Well, all there is decimals between those two. I chose 5.5. 5.5 minus 5 is 0.5. 5.5 minus 6 is negative 0.5. So positive over a negative is negative. Is that greater than 0? No, this interval did not work. Then I go from 6 to infinity. Choose a number between 6 and infinity. I chose 7. 7 on top, 7 minus 5 over 7 minus 6 is 2 over 1. 2, is that greater than 0? Yes. So my intervals that worked were negative infinity to 5 and 6 to infinity. The union. And again, there was no equal to, so parentheses on both of them. Then, number 15 and 16 on 11.5, what we do when we have parabolas like this, we got to find this point here, the vertex. And 15 is this equation. 16 is this equation, x plus 3 squared plus 3. What we do, first thing we do is find the vertex. We take this part, the x plus 3, equal to 0, so our x is negative 3. That's going to be our vertex. I put negative 3 in for the x. Negative 3 plus 3 is 0. Squared is 0 plus 3 gives me 3 for my y-coordinate. And that's the first point I find on my graph. Negative 3, 3, the vertex. See how everything's centered around it. Then I went on each side of that negative 3. I went to the left of negative 3, negative 4. I went to the right of negative 3, negative 2. As I've shown, I put those back in the equation here. Put them back in the equation, and they worked out to give me 4 and 4. I plotted those points. Then I went 2 to the left of negative 3, negative 5. And then 2 to the right of negative 3, negative 1. Again, I put those in my equation, and they came out to 7, and I plotted those points. And then I connected them. I got my parabola. I find some other things. My x-intercept. Where does it cross the x-axis? My graph. My graph never does cross the x-axis. So, no x-intercept. The y-intercept is found by putting 0 in for the x in our original equation. 0 plus 3 squared plus 3. 0 plus 3 is 3. Squared is 9 plus 3 is 12. So 0, 12 is your y-intercept. Then you find your domain. Your domain is, look at your graph here. Well, look at your original equation. Is there any x's in the denominator? No. Or is there any radicals? No. So we can put any real number in there. So all real numbers. Our range, though, look at your graph to find your range. What's the lowest y-coordinate? 3. So from 3 to infinity is our range.